Hi everybody, today's lesson is a complement for lesson number 5 and it's a very important lesson since we have to analyze a structure and use finite element analysis for slabs. Then we have to browse the results and know how to express them. Then go to yesterday's file if you have created one. To draw a curved beam, go to Plan, then select the story at which you want to draw. For this time we choose story number 1. And if we go to beams from this icon, we notice that we don't have any option related to curved beams. As a result, we go to Geometry and Objects and choose Arc from them. Here we have 3 options. 3 methods to draw an arc: center, begin, end, middle, and begin, middle, end. We select the middle one, which is begin, end, middle, and from geometry you can define 3 points, and parameters contain arc discretization, which is the number of segments at which the arc will be modeled or divided. So select it and select the create bars checkbox and start drawing, and the middle point. The next step is to draw a curved slab. We also have 3 options here. We have contour and rectangle and circle. At this time contour is the well suited one, and we have also from here arc discretization. We choose it and choose 10 points. Then start drawing. From here we're still on story number 1. Then close it. As you see, we have created a slab for this portion. Now we choose edit option to copy the contents of what we have done to upper floors. So select everything that you have done in story 1, then go to copy. For x0, for y0, for z we have I think 3 meters, and we want it 3 times. Execute. Now we have to define loads. First of all, load types. We add dead load, delete everything, and live load. Then close it. Now we want to assign loads to different items. First of all, we assign loads to slabs. So select one slab, right click on it, go to select similar by thickness. As you see, all slabs have been selected. even the new ones. All slabs have been selected. Again, do the same procedure. Then go to load definition. As you know, slabs have a surface load, and surface loads are of many types. So the most suited one is the first one, uniform planar load. Let's assume that our slabs have a load of 2 kilonewtons and it's directed downwards, and it's dead load, not live load. Okay, then apply. You can also turn on the loads from here, as you see. Now select all beams just by selecting one of them, and select similar by cross section. Then go to load definition, and beams have a bar type of load. For example, if there is, let's assume that there is walls on all of these beams. On X we don't have, on Y we don't, and on Z we have. Let's make it as 4 kilonewtons. Now I'll show you how to add the self weight. Click on this icon, then press on self weight and mass, and choose the first option and press apply, then close it. After that, add loads on this curved beam. How to do that? Right click on one beam and select similar by cross section. As you see, all of them are selected. Then go to load definition and choose it as bar, this one, and write -2, then add it. Now we have to assign live load to all slabs. So select one slab and select similar by thickness, then press on load definition and add live load. Just write -3, okay, that's enough. Then add it, apply it. Now we set load combinations. Here we have a list of codes, available codes, ACI 318 2002. We can analyze according to this code, but at this time we're gonna use manual combination. We name it as ULS as ultimate limit state. Live load, we edit the factor and set it as 1.6. as customized, and the the dead load as 1.2. Apply, then close it. So we have ULS. This is what we have defined, and then start calculating. As it's shown, we don't have colors indicating load transfer mechanisms from slabs to beams. That means we have to disable finite element. Select all slabs. By thickness. Then go to floor. Okay, from here we have shell. We label it as shell 1 or any name. No finite element. And simplified trapezoidal and triangular method, make it two-way and add. Then close it and choose it. Then apply. Then close it and start calculating again. As you see, we have load transfer regions. To show forces directions, right click on any place and go to display, and from that go to loads, as we did in the last videos. Select the first checkbox under the moving loads, then apply and OK. As you see, this is the load patterns. Okay, now turn them off. At this moment, we need to know the maximum moment around y-axis and the minimum moment around y-axis acting on beams. So select one beam and right click, select by cross section. All beams are selected. Now go to front, then disable the sections and open in a new window, just like that. Then go to results, diagram for bars, and from here set the parameters as text and differential. And if you want filled patterns, no problem, then go to NTM again and select the checkbox of MY, then apply. Click on normalize, and as you see, this is the result of the moment around y-axis. As it's shown here, the maximum positive moment around y-axis is 104.42, and the maximum negative moment around y-axis is 177.63. And to show the results in a tabular form, go to Results, Forces. As it's shown here, we have Fx, Fy, Fz, Mx, My. This is My. This was how to show the forces acting on beams. To show the maximum values, go to Global Extremes. As it's shown here, the maximum value of My is 127, at bar 397, and at node 270. All these details represent the maximum values of forces. For axial forces acting on columns, we select one column and right click on it, select by cross section, then go to front, disable sections from here and open in a new window. After that we go to Results, Diagram for bars. From Parameters we want Text Differential Field. We go back to NTM, FX Forces, then Apply. As it's shown here, forces increase on columns as we go down. That's why columns cross sections decreases as we go up. And it's also shown here the maximum axial force on columns, that is 2046 kilonewton, and the minimum is 193 kilonewtons. We follow the same procedures to show the tabular form of data, that is results, and from results, forces. And to show the maximum values, we go to Global Extremes. We have here the maximum value of axial force on columns at bar number 73 and node number 43. For the analysis of slabs, we will not get any results since we didn't use the finite elements method. Then we have to convert them to finite element method. Then select one slab and select Similar by thickness. Then go to Calculation from the Geometry box, and from here change it to Shell, and then do the calculations again. As it's shown here, the mesh has appeared. Select one slab, go to Plan, select one slab and open it in a new window. As it's shown here, this slab is two-way slab. To get detailed results regarding this slab, go to Results, and from there Maps. From Detailed, we want moments in the direction of x-axis. This is the shape of the moments in the X direction, and to show the moments in the Y direction, check this checkbox, then apply. And to show its values, click on this one and then press on apply. And to show the extreme points, select this one and press on apply. This is the extreme point. You have many options here. We go back to maps or isolines, like this is isolines. The last part of this video is related to slab cuts. So how to do a slab cut that illustrates the forces or moments at a particular section. Well, go to top view and from here select the slab. Let's assume that this one is the selected one. Make it as store in buffer and select it again. Then open it in a new window. From results, go to panel cuts, and from detailed, choose moments XX, and from definition, choose parallel to plane through a point, and choose that your plane is XZ, not XY. Then choose the point that you want, for example this one, and press on apply. As you see, we have cross section AA. Go to front. Okay, front. This is front, and as you see, this is the moment in this slab. To see the values of these moments, go to panel cuts again, and the slab is still selected. Then from diagrams, select text, and from here filled, and apply. As you see, this is the value of the moment in this slab. That was our lesson for today. Thanks for watching. If you have any questions, just do not hesitate and write them in the description below or send them to my WhatsApp.